We can also use u-Substitution to figure out definite integrals. In this case, the formula is a little bit different. It looks fairly similar. We have the integral from a to b of f of g of x times g prime of x dx. That looks similar. We're also going to use the substitution u equals g of x. And we're also going to end up with a new integrand of f of u du. But now we're going to have new limits of integration, g of a and g of b. So when we do a u-Substitution with definite integrals, in order to get an equality here, we have to change the limits of integration. Let's see how this one works in an example. Suppose we want to integrate 1 to 3 of x cubed plus 5 to the 9th times x squared dx. Well, we might not see how to do this immediately, so let's think of potentially using a u-Substitution. So we'll try something and we'll see if it works. The natural thing to try here is x cubed plus 5. And that's going to work out pretty well. You could see it in advance. The derivative of x cubed plus 5 is going to be 3x squared. We have the x squared sitting here, and the 3 is just a constant. So if we let u equal g of x, that's what we have here. It would be x cubed plus 5. du will be 3x squared dx. We need to substitute for the x squared dx. Again, we have to get rid of all the x's and dx's. So we just divide by 3 to get x squared dx. So du over 3 is x squared over x squared dx. So in for x cubed plus 5, we can put u. And for x squared dx, we can put du over 3. But to apply this formula and to get an equal sign here, we also have to calculate g of a and g of b. G of a is what we get when we put in 1. 1 is a in this case. It's the lower limit of integration. So we just put 1 into g of x. So this turns out to be 1 cubed plus 5, or 6. We also calculate g of b. And b in this case is the upper limit of integration, which is 3. So we calculate g of 3, put 3 into this expression. That's 3 cubed plus 5. 3 cubed is 27. 27 plus 5 is 32. So this integral that we started with, the integral from 1 to 3 of x cubed plus 5 to the 9th times x squared dx, that's the integral we started with. That's equal to an integral from 6, that's 1 cubed plus 5, up to 32, that's 27 plus 5, of u to the 9th times du over 3. This is a much simpler integral to figure out because we can figure out an antiderivative for u to the 9th. We can pull the 1/3 out in front. Integral from 6 to 32 of u to the 9th du. That's just 1/3 times, using our formula for antiderivative here, it's u to the 10th over 10. We need to evaluate between 32 and 6. So we have 1/3, that's out in front of everything. We put in 32 for u, 32 to the 10th. We put in 6 for u, 6 to the 10th. Each of them divided by 10, with a subtraction in between. And that's the answer. And if you really wanted to simplify that, you could simplify it to this, if you wanted to do enough arithmetic. This is u-Substitution. It's a powerful way of doing integrals. Again, it takes some practice to figure out what u should be, and you have to make sure that you get rid of all the x's. And if you don't, it just means that either the substitution didn't work or you don't know how to integrate this thing. And there's lots of integrals you're not going to know how to do. We try to make integrals in calculus, ones that you can do with the techniques that we have. But remember, generically, u-Substitution won't work for every integral, and you have to make sure you get rid of all the x's to get a valid expression here.